Hey guys, just want to show you how to use the graphics calculator for the purposes of drawing a scatter plot today. So I've just got a textbook question that I'll be working off of, but any question where we're drawing a scatter plot, this video will be handy. So with your graphics calculator, you want to go into your statistics mode. Just make sure you're watching my mouse cursor in terms of pressing the buttons so you can kind of follow along just to get a sense of how the buttons work with the calculator. So executes your enter button, and then these F1 to F6 buttons are going to be supporting us to press the options in the calculator. So we'll go into the statistics mode, and then essentially there's lists to input your data. So over here, question 10, we've got rainfall in millimeters as one axis or one variable that we'll be plotting. And then we've got growth in centimeters, which is the second variable that we're going to be plotting. And what we're looking for is there any connection between these two variables? So that's what the correlation is. So first of all, we'll start to input the data. So this bit is a bit, I guess, tedious, takes up a bit of time, but we're just putting in all those numbers. Whoops, 560, 830, 680, 650, 720, and 540. And then we'll move across and we'll go to the second list, and then we'll put in the second variable, just all the data in there, 25, 85, 50, 55, 50, and 20. Now it's good sometimes to just double check, so you can just go up and just make sure that your numbers are correct. Because it's pretty common when you're inputting data that doesn't really have any real significance to you that you make a mistake, but that seems to be all good. So now what we're going to do is look to graph that data to make a scatter plot. So again, this will save us a lot of time. So what we're going to do is go into the graphing function up here. So you can see graph, it's associated with this F1. Okay, so we're going to click graph here, and we're going to go to F6, and we're going to set everything up. So this is the settings for the graph. So you get a bunch of settings here. If we go down the graph type, we just want to make sure that's a scatter plot. So we've got it on scatter, which is F1, which is what we want. If you go across, see F6 correlates or corresponds to that little arrow, which means there's more settings. You can draw a histogram, a box plot, F2, that's a median box plot, bar graphs. There's a lot of different options that we can select. But for the purposes of what we're doing, scatter plot is fine. So if that was on something different, just say it was that one there, I just want to click scatter F1. We want to make sure that the list 1 is the x-axis, which is the horizontal axis, and list 2 is the y-axis, which is the vertical axis. You can just leave that as is, that's fine. Make sure the frequency is 1. You can sometimes change that, but essentially that's talking about the scale of the graph. There's a few more settings here. We can change the color if we like, if you have a color graphics calculator. And we can change things like the data being crosses instead of, I guess, squares or whatever you want to do. So there's just a few different options there. So anyway, we'll press enter once we're done with that. And if I go back to set, you can make sure that this is stat graph 1. So your calculator you can draw 3 graphs at one point of time based on a lot of different data. So stat graph 1 means that we press graph 1 every time. If we change that to graph 2, that means we'd have to draw graph 2. So we'll leave it as graph 1. So we're happy with that. And now we're going to actually press graph 1, which is F1, and we get our graph here. So that's our scatter plot, saves us a bunch of time instead of drawing. So from here we can do a few things. We can press the calc button, and we can go to the X here. And we've got two options. We're going to click AX plus B. You might remember that the equation of a straight line, or of a line, is y equals mx plus c. So essentially, instead of mx plus c, we have ax plus b on this calculator. So we'll do that. And that gives us a bit of info. So the equation of the line, the coefficient of x in this instance is this, a, and then the constant variable b is here. So basically that just gives us a bit of information for the equation of that line. And some of this information is quite important, particularly the R squared, which is the coefficient of determination, which tells us how strongly these variables are associated with each other. We'll learn about this a bit later, but this is a value that we'll be looking at in the future. Now we can click draw, and we'll draw the line of best fit. So essentially a good line of best fit will have the data evenly distributed above and below that line. So it's kind of like cutting right through the middle. So that, I guess, shows that. If you drew one manually, we'd hope that it would get pretty close to that. So that's essentially it. There's a few more options, one of which is we can do some interpolation calculations where you get a point on that line of best fit and you can get both of the variables, the numbers. So I'll show you how to do that quickly. We can go Shift, so the Shift button here, and then F5 for Gsolve, and we can do a Y calculation. Now if I look back over here, my X values are the rainfall, okay, in millimeters, 450, 620, etc. So based on that line of best fit, I can do some interpolation. So I can say, for example, all of these numbers here, we don't have anything for a 500 millimeter rainfall. So I could do 500 in here. And essentially, this is 500 on the x-axis, and it calculates that the y value, which is the growth, will be 22.4 centimeters based on that line of best fit. And you can kind of see where it fits, that little pink cross there. Okay, so we can do any calculation for an x value, and we can get a y value. If I do 450, now 450 corresponds to 25 centimeters growth. However, based on the line of best fit, that data point was significantly above our line of best fit. Okay, so once we've got more data, you can see that that point is a little bit over. So based on the line of best fit, the growth is predicted to be 14 centimeters, not the 25. And the more data we collect, the more accurate that line of best fit will be. So this data here, we've got 8 data points, so it's not super accurate, but if you were to get 8,000 or 80,000 data points, it would be much more accurate, that line of best fit. Alright, thanks for watching. Hopefully this helped a little bit drawing a scatter plot and drawing in a line of best fit and doing some calculations. Thanks.